Alright, in this video I'm going to go through the other part of the review, which covers sections 3.2 through 3.6. I won't be doing all the problems, but I want to go through and I'll do several of the problems and just kind of give you some tips. So first of all, number one, if you're dividing by a trinomial, you're going to have to use the long division technique. So, and the other thing I want to point out here is notice there's no x squared term. So we're going to have to put in a 0x squared for that term. So I've gone ahead and set this up. So now we want to look at the leading terms here. And we're asking ourselves how many times, or I should say what times x squared gives you x to the fourth. And that would be x squared. And so we'll put that in the x squared column, and then we'll multiply each of these three terms of the divisor by x squared. We're going to get x to the fourth minus x cubed plus x squared. Now I have to subtract that from what's above. X squared minus x to the fourth is 0, which we would expect. We've got negative 3x cubed minus a negative x cubed. That'll be plus a 1x cubed, so we'll get negative 2x cubed. We've got 0x squared minus x squared, so we'll get a negative 1x squared or minus x squared. And then we need to drop that 2x term. Each time we should end up with three terms because our divisor has three terms. So now we look at the minus 2x cubed and we ask ourselves what times x squared gives us minus 2x cubed, and that would just be a minus 2x. And so when we multiply, we get a negative 2x cubed plus 2x squared minus 2x. Again, we're just multiplying negative 2x times each of the three terms in the divisor, and then we're going to subtract. So we're going to end up with 3x squared, because we have negative 1 minus 2x squared, so we're adding negative 1 and negative 2. And then a 2x minus negative 2x, that'll be a plus 2x, so we get 4x. And again, let's bring that minus 5 down. So one more time, it looks like here we need to multiply x squared by a negative 3. And so we'll get negative 3x squared plus 3x minus 3. And again, we'll subtract that from what's above. And 4x minus 3x is x, and negative 5 minus negative 3 will be a plus 3, so we get negative 2. So the way we write our answer, what we have here is our divisor, or our quotient, which is the main part of our answer, and then our our remainder, x minus 2, it will be written over what we're dividing by, the x squared minus x plus 1. Notice on number 2, because we're dividing by a linear polynomial, because the degree here is 1, we can use synthetic division. So let me go ahead and set this up. So we're going to want to put 2 in the box, and our coefficients are 5, negative 6, 3, and 11. We need to drop the 5, and then we do multiply, then add, multiply, then add until we're done. So we'll multiply the 2 and the 5, we get 10. Add negative 6 and 10, you get 4. Multiply 2 times 4, you get 8. Add, you get to 11. And multiply, you get 22. When we add, we get 33. So remember, in this problem, our leading term is cubic, and we're dividing by a first degree polynomial. So that 5 that we just got here represents 5x squared. Whoops. And then, so plus 4x and a plus 11. And then our remainder is 33 over our divisor, x minus 2. All right, let's move on to the next problem. Notice on number 3 we would have to use long division because we've got a 3 right here. It has to be a 1, it has to be to the first power in order to use synthetic division. So we should be using long division there. And I won't do that, but you can look on the answers and see the details. On number 4, we can use synthetic division, but notice you are missing the x cubed term. So just keep that in mind when you set things up. So -3 would go in the box, and you would set it up like that. And I'll let you take it from there. Let's look at number 5. It says find all the zeros of the function. Now I want to remind you, one of the things we talked about is when you're finding zeros, you always want to try to factor first using our old techniques. We shouldn't use any synthetic division unless we really have to. This first problem has 4 terms, so it looks like we can factor by grouping here. So always want to factor if possible. So we can factor out an x squared in those first 2 terms times x minus 4. So when we factor the second 2 terms, we should get an x minus 4. And it looks like we're going to have to multiply by 3 here. So we're going to end up with, let's see, x minus 4 is our common factor times x squared plus 3. And we want to set that equal to 0 so we can find our zeros. When you set x minus 4 equal to 0, you get 4. And then when we set x squared plus 3 equal to 0, we're going to want to subtract 3 on both sides. And to get x by itself, the opposite of squaring is taking a square root. So let's take the square root of both sides. Don't forget that plus or minus, which we always do when we take the square root of both sides. We're going to get plus or minus I times the square root of 3. So our 3 zeros are 4, I squared of 3, and negative I squared of 3. On part B, notice we've got a GCF of 4x squared. And we've got 2 terms inside. 4x squared times x squared will give us that first term. Minus 81 it turns out to be. And that's a difference of squares. So this could be factored as x minus 9 times x plus 9. Again, we're setting this equal to 0 because we're looking for the zeros. Of course, a 0 is just a value that makes the polynomial equal to 0. In order to find that, we just set the polynomial equal to 0. So we get 4x squared equals 0, minus 9 equals 0, or x plus 9 equals 0. We're going to get 0, 9, and negative 9. And so those are our zeros. On number 6, it asks you if x plus 4 is a factor of this polynomial. And the answer is yes, if your remainder is 0. Otherwise, the answer would be no. So again, you want to use synthetic division. And if your remainder is 0, then the answer will be yes. So on the test, you just want to make sure that you don't just say yes or no. You got to show or justify your answer using synthetic division. Let's move on to number 6 here, or I guess this would be number 7. Hold on a sec. That's right. So on number 7, we have a polynomial in factored form. It says state the degree of the polynomial and use it to determine the end behavior. So first of all, I want to remind you that when a polynomial is in factored form, we have to look at the exponent on each factor to determine the degree. So the degree, or the degree for the x minus 3 term is 1. So we just add the 2, 3, and 1 to get the degree of this polynomial, which is 6. So that's an even degree, and the coefficient here is negative. And so anytime you have an, whoops, why did I write positive there? Let's fix that. So I want to remind you there's four cases basically. I'm going to go ahead and just put this down for you guys. These are the 4 cases. This is from section 3.2. So basically, for even functions like y equals x squared, we know if the leading coefficient is positive that on each end the polynomial is going to rise, and if the number or the coefficient out front is negative, on each end the polynomial is going to fall. For odd functions, they're going to act like y equals x cubed, which I called the John Travolta function. So if the coefficient in front is positive, it looks like John Travolta, or the end behavior of x cubed. And if you have a minus in front, then it would be a reverse John Travolta, or like I have right here. Alright, so in this case, we are going to be, it's going to fall on both ends. Let's see, and I need to fix that. So it would look like this. Alright, and let's see, it says state the zeros of the polynomial and find the multiplicity of each zero. So notice for the x minus 1 factor, because it's an even power, it's going to bounce at x plus 2, or x plus 2 is a factor, so the 0 there would be negative 2. Now I want to remind you that zeros and x-intercepts are pretty much one and the same, or they're like tied together. So let me do this part first and then we'll answer part B. So we're also going to cross at 3 because x minus 3 is a factor of the first power, which is odd. So with odd powers we cross. If we have an even power we bounce. So let me go ahead and make a chart here. So our zeros are going to be, see, x minus 1 is a factor, so 1 will be a 0. 1, 0 would be the corresponding x-intercept. Multiplicity here is 2, and so that's why we bounce there, or in my math lab it talked about touching and turning. Our next 0 would be negative 2, and we have an odd power there, so we cross, and the multiplicity is 3. For x minus 3, that tells me that 3 is a 0 and the multiplicity is 1, and so we're going to cross there. Alright, so let's do the sketch here. So again, wherever we have zeros, that's where our x-intercepts are going to be. So 1, 0, negative 2, 0, and 3, 0. On the end behavior, it's going to fall on both ends, and I have that backwards, so let me fix that. And then we know that we're going to, let's see, when we get to negative 2, we cross. I always start on the left, and so we're going to cross at negative 2. Eventually we have to come back down. And when we get to 1, we're going to bounce. But again, eventually we have to come... Oh, you know what? I did my end behavior wrong again here, didn't I? Let me start this over again. This should also be down. Alright, so now we can do this. So we cross here, and then we're going to bounce at 1, and then we come back up, and eventually we come back down and we have to cross. Alright, so there's our graph. Number 8. So this is one where it's not in factored form, so we're going to have to factor this one. So first of all, I'm going to factor out a negative. So basically we're just factoring out a negative 1. So all the signs change inside the parentheses. And then let's factor that by grouping. We get x squared times x plus 1. And then we'll have an x plus 1 factor for this other. We're going to need a minus 4 there. We get x plus 1 times x squared minus 4 with a negative out front. So we can go ahead and rewrite f of x in factored form. Notice we also have a difference of squares here, so I'll go ahead and take care of that too. So x minus 2 times x plus 2. And so we're going to have 3 zeros. I guess we'll get to that in a sec. We've got a leading coefficient that has a degree of 3, and so that's going to be the degree of this polynomial. And we have a negative out front, so we're odd and negative. And so our end behavior is going to be reverse John Travolta. And now we can talk about the intercepts and the behavior at each intercept. So we're going to have negative 1, 0, or zeros are negative 1, 2, and negative 2. So the corresponding x-intercepts are going to be negative 1, well, I'm sorry, each of these to the first power, and so we're going to cross at each of these because they're odd. So our intercepts are going to be negative 1, 0, 2, 0, and negative 2, 0. And we're going to cross at each of those. The y-intercept's pretty easy here, because if you put in 0 for x, everything zeroes out except for the 4. So we get 0, 4 when we let x be 0. And let's look at the symmetry. Remember, to determine if you have y-axis symmetry, origin symmetry, or neither, you've got to plug minus x into the graph, or into the equation. And it's going to change. Let's see, for minus x cubed, that's going to be negative. And so, or negative x cubed, so we'll have a negative x cubed. That one changed to positive. A minus x squared squared is just the same as x squared. So the sign doesn't change there. We're going to have a minus 4x and a plus 4. So notice some of our terms change signs and some of them don't. So we're not equal to the original function. We're not equal to, that would make us an even function. We're not, our terms are not all opposites, so we're not getting the opposite of the original function, which would make it an odd function. So this is the neither case. So we don't have any kind of symmetry here, at least none of these kinds of symmetry. And so now we're ready to graph this thing. So let's see, let's put in our intercepts and our end behavior. Let's go ahead and put that in. And then we're going to start from the left and go to the right. And so starting on the left, we cross here. We have to eventually come back up here and cross, and eventually we'll come back down and cross. So notice that matches my end behavior. We could put our y-intercept at 0, 4, but that's not really that important. We don't know that that's the highest point, so what we have here is good enough. Let's go ahead and move on to the next problem. Let's see, on number 9, I asked you, or I told you didn't have to worry about it, but I thought I'd do this just so you can see how it works if you're interested. So first of all, notice you've got some intercepts here. Negative 2, 0 is an intercept. And notice it bounces at that point. And so that's got an even degree. Let's go with the smallest, which would be a 2. So our function's going to have an x plus 2 to the second power. And then we've got two other x-intercepts, one at 3 and one at 5. So at 3, 0, we're going to cross, or we do cross, and so that's going to have a degree that's odd, and we'll just use 1 there. So x minus 3 is a factor, and then x minus 5 is also going to be a factor. And notice this is going to be a 4th degree polynomial if we add 1 plus 1 plus 2. And then negative 1/30 is our leading coefficient, so that just goes in front. So we didn't really spend time on this type of problem, but that's how it works. And you'll notice the end behavior does, it is even, it does, so let's see, we said it was degree 4, and it does go down on the ends, and our coefficient is negative here, so that all matches. Whoops, I'm sorry, let me go back so you can see that. Alright, let's move to number 10. So here it says find the zeros of each function. Notice on A, this is 4 terms. So you could try factoring by grouping, but it actually doesn't work. So these are problems where we are going to have to use synthetic division. So I think I'm going to go ahead and let's go ahead and stop the video here.